So as you can see on the board right now, we're going to solve some examples involving pH and pOH. So we start with pH. Now this question states that calculate the pH of a 0.0001 molar solution of HCl. Now how do we go about this? Let's look at it together. Solution. Remember, HCl is hydrochloric acid, and you know, because we have hydrochloric acid, that means we have been given the concentration of hydrogen ion that is present in the solution. So we have concentration of hydrogen ion now to be equals to 0.0001 molar. So this can be written as hydrogen ion concentration. Hydrogen ion concentration. I hope you're with me, and I hope you're following in step. If there is anything that you find a bit difficult, you can actually drop your message, okay? So now the hydrogen ion concentration is equals to this one. Now if you convert this to standard form, you're going to have 10 raised to the power of minus 4. So that is molar. So now this is the concentration of hydrogen ion. Remember, our pH itself is equals to negative logarithm of hydrogen ion concentration to base 10. So let's put this value into this formula. So we're going to have pH to be equals to negative logarithm of hydrogen ion now is 10 raised to the power minus 4, then base 10. So remember, in your mathematics, there is a law that states that when you have log of A, log of B to base A raised to the power x, this will be equals to the x will drop down, then you have x log B to the base of A. So the same thing is applicable here. This minus 4 will drop down. So my pH is going to be equals to minus 1, which is here already, multiplied by the minus 4 will come down, then log of 10 base 10. So at the end of the day, we are going to have something like this. What is minus 4 times minus 1? That is 4. But what about this log 10 base 10? There is another law in logarithm mathematics that states that log of A to base A is equals to 1. So my pH now is equals to minus times minus will give me plus, that is 4 multiplied by 1, that is. So the solution to this question is actually 4. So that is the pH. And apparently this solution would be surely acidic. As you can see, it is an acidic solution. Why? Because the pH is less than 7. Alright guys, so we're going to consider another case study entirely so you can get yourself familiar with how to solve questions on pH and pOH in different dimensions without any form of difficulties. Alright guys, it is very important that you have your calculator or your 4-figure table with you when going to the exam hall, especially when you know you're going to be coming across questions involving pH and pOH. Pay that at the back of your mind. Very, very important. Okay, so now let's consider the question on the board and see how we can actually solve it. So how do we deal with this kind of question? Let's see it together. Now, many times I used to tell my students this: when you see calculation in chemistry, the best way to tackle them is to discover what you have been given from the question. Pay close attention to the parameters or the criteria provided, and then be mindful of what you've been asked to calculate. Bear this at the back of your mind always. So let's use that knowledge here. So we have, what is the pOH of this? Now, first thing, we have been given the hydrogen ion concentration. So the hydrogen ion concentration is 0.005 molar. This can be written in standard form as 5 multiplied by 10 raised to the power minus 3 molar. Just 3 numbers after the decimal point will give you that. So now, what is the formula for calculating pH? pH is negative logarithm of hydrogen ion concentration to base 10. So now this will give me, put the value of this into this place. So we're going to have negative logarithm of hydrogen ion concentration to base 10. That will be 5 times 10 raised to the power minus 3. So now when you take this one, when you consider your laws of logarithm, you turn it to the addition rule, you're going to be having something like this. Minus, put it outside. This log 5 will turn to something like this. Log of 5 to base 10 plus log of this 10 raised to the power minus 3 to base 10, like this. That is what you have. So the question is this: what is log of 5 to base 10? When you press your calculator, you're going to be having log of 5 to base 10 will give you 0.699 approximately. So plus, this is minus 3 will be dropping down. Log 10 base 10 is 1. So minus 3 times 1 will give you minus 3. So you're going to be having minus 3 here. So apparently my pH now is equals to, what will my pH be equals to now? This is very, very simple at this very point. So my pH is going to be 0.69 minus this. So you're going to be having minus, remember minus is at the back of the bracket already. So this minus this will give you minus 2.301. So eventually what is minus times minus is going to give you plus. So that's going to give you 2.301. So my pH itself is equals to this. So if you have gotten this as your pH, remember one of the formulas I provided in some of the previous videos that we had uploaded was that we have there's relationship between pH and pOH. So pH plus pOH is equals to 14. So now that you know your pH, what else do? Then you substitute for the value of pH so you can get your pOH. So my pOH now is equals to 14 minus pH. So my pOH is equals to 14 minus 2.301, which is going to give you 11.7 approximately. That is the value of your pOH. So and that is the answer for it. So like the question implies, this is a different one entirely, but the same methodology or the same approach is still applicable. So let's look at how you're going to deal with this kind of question. Now, the question says that you should calculate the hydrogen ion concentration and the hydroxyl ion concentration. It is very simple. All you have to put at the back of your mind is this. Try to identify the acid or the base that you have been given in the question. So in this type of question, the acid has been stated. So what is tetraphosphate 6 acid by formula? The formula is, the chemical formula is H2SO4. Now, upon dissociation, writing an ionic equation for the dissociation of H2SO4, we realize something like this will happen. So H2SO4, when broken down in aqueous solution, is going to give us 2 hydrogen ion plus SO4 2 minus. As we can see, you should learn how to balance ionic equation. Very, very important. But should you not know, let me give you a clue. The clue is this. The overall charge must give you 0. Now you can see we have 2 times plus 1, that is plus 2. Then this is minus 2. Minus 2 plus 2 will give you 0. On the other hand, this is hydrogen. The charge on hydrogen is plus 1. But because we have 2 here, so we have 2 hydrogen ion to balance it here. Then SO4 is an ion, that is a cation. So an anion, so and the charge on the anion is SO4 2 minus, that is 2 minus. That is why it is written here. So you have it here. So to balance out, we have decided to put 2 here. So take note of that. Now what this implies is that from the question, you have been given the hydrogen ion concentration. But because you have 2 hydrogen ion concentration, 2 hydrogen ion being produced here, so you are going to have to multiply this by 2 to get your hydrogen ion concentration. So please do not forget that. That is very, very important and quite essential. I hope you understand this. So now we're going to have this now as our main thing now. So the hydrogen ion concentration now will be equals to these 2 multiplied by the initial hydrogen ion concentration given from the question, which is 0.003. So at the end of the day, we're going to be having this to be equals to 0.006 molar. That is the hydrogen ion concentration. Now, if hydrogen ion concentration is equals to this, then we have been able to get the hydrogen ion concentration as expected of us. What then is the hydroxyl ion concentration? Remember, in one of the formula I gave to you earlier, I said hydrogen ion concentration multiplied by the hydroxyl ion concentration. Everything must give me 10 raised to power minus 14. So apparently what this implies is that what is our hydrogen ion concentration from the question? We have 6 multiplied, that is 0.006 multiplied by the hydroxyl ion concentration. Everything is equals to 10 raised to power minus 14. So at the end of the day, we're going to be having this now. We're going to be having something like this. So we have, converting this one to standard form, we'll have 6 times 10 raised to power minus 3 multiplied by the hydroxyl ion concentration everything is equals to 10 raised to the power minus 14. So my hydroxyl concentration now will be equals to 10 raised to the power minus 14 divided by 6 times 10 raised to the power minus 3. So at the end of the day, we'll be having something like this, which is hydroxyl concentration will be equals to 10 raised to the power minus 14 plus 3. If you don't know, don't bother yourself how to do the standard form. You just have to learn it. They make calculations like this very, very easy. So eventually you're going to be having something like this. You're going to have 10 raised to the power of minus 14 plus this, that's minus 11. So our final answer is going to be 1.6. So our hydroxyl concentration now, the hydroxyl concentration eventually has gotten is 1.67 times 10 raised to the power minus 12 molar. So please pay close attention to that. That is how to deal with such questions. So by so doing, we've been able to use the second formula again. Let's move to another one.